Hi, Dr. L. My name's AJ Haskins, and I'm giving my presentation on the Morinaga Milk Arsenic Poisoning incident. So, the history of the company, a little bit of background. It started in 1917 with a different name in Tokyo, Japan, which is located right here on the map. And the company's goal was to create milk products. And the first product that they launched was in 1919, which was condensed milk and is right here in this aluminum can. And then shortly thereafter, they introduced their dry milk, which was the infant formula, which is in this can down here, the blue one. And I wanted to note that some of the safety precautions for Morinaga were ignored by the food manufacturing industry because competition was really strong at this time because there were only three corporations that were really successful in the milk industry. So instead of looking at quality assurance and quality control, they were looking more at optimization and competition. In April of 1955, arsenic was accidentally introduced into the dry milk, and this happened because Morinaga was using a food additive called disodium phosphate. And they used disodium phosphate to maintain the acidity of cow's milk. And unbeknownst to Morinaga, the additive contained 5 to 8% arsenic, and more specifically, arsenic acid, and some trace amounts of sodium arsenate, which, as we know, is very toxic. And the arsenic was introduced in the process of using a rock called bauxite to produce aluminum while they were making their aluminum cans that hold the dry milk. And so that in that process, the byproduct of that process was the arsenic. And this accident resulted in the deaths of 130 infants, and 13,000 more were exposed, and thousands within that 13,000 rather, experience long-term and short-term side effects. Arsenic acid was the main form of arsenic that was found, and it's inorganic. It occurs in aqueous solutions. It actually hasn't ever been separated on its own as like a single substance. It's only been found in aqueous solutions, and it's derived from the hydrolysis of arsenic trioxide, which, as we know from class, is also very toxic. The most common routes of exposure for arsenic acid is ingestion and inhalation, and it can cause side effects in the brain, liver, reproductive system. It's carcinogenic, and it can cause aplastic anemia. So the introduction of arsenic started in April. Now the symptoms started to begin in June of 1955. And the primary route of exposure in this particular case was ingestion because of the ingestion of the formula. The dosage of arsenic in the baby formula was 4 to 7 milligrams per liter, or 4 to 7 parts per million. And as we know, the national limit is 10 parts per billion. So this is quite a high amount. It was determined that a dose of 5 cans or 60 milligrams of arsenic was enough to cause clinical symptoms for the infants, and that would be ingested over 2 to 3 weeks, depending on the size or the age of the infant. Over to the right, I made a chart that has infant dosages of arsenic, and they did this by age and by weight because sometimes you might give an infant a certain amount based on what their age is, or sometimes you might go by how much they weigh, because some babies are bigger than average or smaller than average. So that dosage can change, and also by how much you dilute it. They also said in some of the literature that that will affect the dosage as well. But these were estimates based on how often a child at each age or each weight, how much they would eat a day. So then I looked at another paper to show some of the uh, short-term toxicological effects, low weight, the keratoses that we talked about in class, diarrhea, vomiting, fever, abdominal distension, and these were mostly seen in infants that were less than 12 months of age. So obviously this was very concerning for parents. And then a separate paper talked about the long-term toxicological effects. They looked at around 6,000 survivors. In the paper was written in 2020, so they looked at about 6,000 people, and they found some interesting stuff, even though there isn't a lot of data. They found a higher mortality ratio in diseases in the urinary, respiratory, reproductive, and nervous system. They also found a higher risk of motor traffic accidents, and I found this interesting. They found that people who were exposed in this incident were 2 times more likely than the general public to die in a motor accident, and they had two possible causes for this. One of them was decreased motor function because of the arsenic exposure, again, with the neurological effects. And also, they did a survey in 1971 of some of these survivors and found out that there was an increased risk of, well, prevalence of macular degeneration. And so those two things could contribute to being more likely being in a traffic accident. And that's not that wasn't one I expected, but it makes sense. And also the risk of death from liver cancer was also significantly increased. So the way that this was discovered, a doctor that worked at Okayama University, he was a professor of pediatrics. His name's Dr. Hamamoto. He realized by the presentation of symptoms in these infants that it could be a metal or metalloid that was causing this. And I found this to be very impressive because before that, it was just thought that it was a just some like weird, obscure disease. So good on Dr. Hamamoto for seeing that. And it was also thought to be in the dried milk powder because all of the victims were bottle fed. And it wasn't hard to narrow down which company either because there were only three major players in that market. So then the Department of Forensic Medicine at Okayama University, they confirmed that arsenic was present in Morinaga's dried milk. Then they also did an autopsy on one of the infants, and they found arsenic in the liver and hair of the deceased infant. And by August of 1955, the director of health of the health department released this information to the public, and the dried milk from Morinaga was banned in Japan on the same day. And so the timeline, just once again, the introduction of arsenic was in April, symptoms in June, public notification in August. So in some ways, this whole incident changed Morinaga, and it also changed, or well, yeah, changed toxicology. Uh, some of the changes are as follows. So health risks from infant foods were not studied or well known in the 1950s, and there just wasn't a lot of research there. So I think that this incident could have. That's why I hesitated about how it changed toxicology. I don't know that it did, but incidents like this, along with many others that our class is going to talk about for this homework assignment, I'm sure did contribute to how we now look at infants, especially because they are more vulnerable because they're smaller. Morinaga also was not motivated to continue research in this incident, and I would speculate that that's because they were fighting legal battles about this. They did not think that they were guilty, and I think putting money towards investigating long-term effects would be almost an admission of guilt. So I think that may have contributed to them not wanting to do it. But scientists have translated the information from Japanese to English so that way more people could be aware of what happened. And they've also conducted cohort studies on the victims. One of them from 2020 I used in this PowerPoint. Um, Tissue concentrations and exposure levels were not able to be accurately determined, nor was there dose response relationships that could be determined because of Morinaga's lack of cooperation. And the importance of quality assurance and quality control was highlighted in this case because of the disodium phosphate additive being contaminated. So it makes us think about, checking and rechecking everything, especially in the food process where people are going to ingest things because that's such a common route of exposure. Uh, Morinaga does now have quality control measures that they utilize in 4 categories, which include product development, raw material procurement, production, and distribution and sales. And we also now understand that just because symptoms of acute toxicity diminish, it doesn't mean that the story's over and that they can't have long-term effects. And that was a major uh, part of this study as well, because some of these numbers might be deflated because they didn't consider uh, once patients their symptoms from acute exposure were gone, they said they were cured and that was it. And they didn't look at them in the long term. And we now know, and maybe from this incident and picking up the research uh, only 5 years ago, that that's not true. That we do still see long-term side effects even from an acute exposure where someone was able to survive it. And these are my sources. And thank you very much for viewing my presentation. And I will see you next time.